if you had 8 bits of data and 7 of those bits were ones, if you had a so-called even parity, we would add a bit to make it an even number. If we had odd parity, we would make sure it was an odd number. That was very simple parity bits. Then we went a little bit more complex and we started adding cyclic redundancy checks, or CRCs. You see today, unfortunately sometimes, your PC will say that you have a CRC error on the hard disk. Every file that is, every block of data that is written to the hard disk has a CRC checksum with it. And that is done in the hardware. So the hardware, it writes data to the hard disk and then adds a CRC afterwards. And when it reads it back, it just says, I add that up again, and is it the same as a CRC? Simple and effective. Now, there are more flavors of CRC than just one. But that doesn't matter. It's just the basic idea. Okay, the MD5 checksum. What is that? Well, I'm getting a bit of echo here, I think. It is a so-called message digest. Now, digest in English means to eat. So when you eat something, you digest it. And this is just, I'll keep talking. This is just designed to eat the information and to give a particular result back. It was designed back in 1991 as a replacement for MD5. Sorry, for MD4. And before MD4 was an MD3. And before that, lo and behold, MD2, doesn't matter. It was designed by Professor Rügenblick of the MIT in America. And it was just meant to be a far better checksum than all previous checksums. An MD5 checksum uses a 120-bit hash value. Hash, we just mean adding up. But how it adds it up is, of course, the trick. If we have a look at, for example, this message, the quick brown fox jumps over the lazy dog, which is generally used to check that you can use every character on an English keyboard. That becomes translated as 9E107 and so on. And what you see here is that's 128 bits, but now hexadecimally shown as 32 characters. Yeah? So, that's what an MD5 checksum looks like. What the MD5 checksum does, it processes a variable length because no one knows exactly how much data is going to come in. It could be any length. And it makes it into fixed lengths, and that should be bytes, by the way, 128 bytes. So it makes fixed lengths. He breaks this up into chunks. And he makes 512-bit blocks. And he does this by just padding extra information onto the data you've supplied. So it is always able to be divided by 512. So it always has a fixed length to work with. Each block is then broken down into 32 bytes. There's something wrong here with the bits and bytes. It must be bytes. It's about 32 bytes and added and ORed in a particular fashion, such, and depending on which block is selected as well, to form the checksum. The reason it's done like this is to make sure that no two bits of data coming in, irrespective how big or what, will never get the same number. That is the ideal of a checksum, uniqueness. Now we'll spend the next 10 minutes going through this diagram. No, seriously. this is the way it works, but it doesn't have much sense to tell you how it exactly works. But that is how it works. You see, you just add up the data in a particular way. And it's in such a way, mathematically done, that it is a very, very good method of creating a unique number. If you want to look up more, there's a lot more on Wikipedia, but it's no sense to tell you exactly how this works here. Just take from me, it works. You will find in documentation here and there something called collisions. Now, a collision is the term given to the possibility of having two different pieces of data give the same checksum result. That's what they call a collision. The possibility is, I think, something like 2 to the power of 128, which is fairly small. But back even in 1995, a couple of mathematicians were working on the problem to see, can we produce a collision? And they managed to find it, both in MD5 and SH1. SHA1 is another form of checksum. In 2005, researchers even managed to create 2 security certificates. So one is a real and a proper security certificate, and the other one is an invalid one. Just by manipulating the data. So in other words, it's rather like you go to your bank and say, hello, I'm Harry. And somebody else comes and says, hello, I'm Harry, but you're not. And that is a problem, because certificates are used as a validation on internet for all sorts of things, and not only on internet. But up till now, there have only been 2 cases in which there are only 2 ways in which they can do this. And it is not by changing the data within the original stream, but by adding data to a stream. So the length has to change. So in other words, if you had 2 pieces of data, they can never have the same checksum if they're the same length. That is what this in fact says. Now, for data integrity checks, that's what we will use it for, this doesn't make any difference. I mean, nobody's going to fool around that much to try and create something which says it's the same as what you think it is. At least if we're talking about files. I mean, if you're trying to log into a bank or something, it would be a slightly different question, but then we're not talking about validation. If you're talking about certificates, then it is a problem. Now, we're not going to use it for any form of certificates, but just purely and simply to check the files are as they should be. Where is it used? Now, as I said, basically it's used to check the pieces of data are the same. Now, of course, you can say, well, you can always compare 2 files that they are the same. But that means you have to read the file both times at both sides. If you have just a checksum, you only have to check that what you've got is equal to that checksum. Supposing a file is transferred across the net. If you also transfer the checksum with it, at your end, you can easily check that that file is correct. Because file transfers are not guaranteed to be 100%. And I think everybody here has had at one time or another copied a file or transferred a file and it is not quite what it should have been. You can also do it if you burn files on a CD, for example. If you burn files on a CD, you think you've burnt it correctly. Now, you could go and compare everything on that CD with the original. If it's an ISO, well, you'd have to break down the ISO into the various files and so on. But it is a very good tool just for checking your ECS 2.0 download is correctly burnt on your CD. Many people have burnt CDs and had problems. Is it good? Is it not good? It is also used to create difference files. Those of you who've downloaded via eComStation often as not have seen that not only could you download the complete file, but a so-called difference file from the previous version. Now basically what MD5 does is if you have, for example, a file of 10 megabytes and you make a checksum of every megabyte and you have a new file and you do exactly the same, you will see where the changes are. 9 times out of 10, there are only small changes in files, and 90% of what was there was the same before. So in this way, you can just separate the bit that was different, send that across a network, at the other end, recombine it. And that's what you do with some of the diff utilities. Why use MD5? Good question. First of all, it's platform independent. You've got software on Linux, on OS2, DOS, and even on Windows. There are various programs, as I was saying, that can generate MD5 checksums. It was devised for 32-bit machines. Well, if you're talking about 1991, now we know why. But it is also very fast. There is one thing, I put this in here today. As far as I know, there is nowhere, anywhere, programs which make checksums of the EAs. So normally when you check a file, you're just checking the file data, not also the extended attributes. There may be a program out there somewhere, but I have never hit it. But I never looked for it, honestly. Okay, how do we use it? Now, first of all, in order to know if a checksum is correct, we need two things. The checksum itself, obviously, and of course, the file name. So if we have a file name and a checksum, we can check that that file is correct. Here is an example. This is the OS2 program called MD5. Simply MD5 file name, and you will get, as you can see on the example, the list underneath of the MD5 checksum for that file. Now, if you wanted to check it, you would need to know what the MD5 checksum should be, and then physically read that and compare, or with a little bit of a rec script, compare it. Or you might have a file which contains both the checksums and the file names. So if you want to check more files, this is a more handy method. So this is the standard, and this is platform independent. You get first of all the checksum, a space, an asterisk, and then the file name. You notice immediately there is no drive number. Because we don't know where that file is, it's just the file itself. So, some checksums you will have hyphens in them, and it makes it a little bit easier to read. But I should warn you, not all programs accept the hyphen when you're trying to read the file. Some do, some don't. Okay, command line programs. Using MD5 is the diff utilities, but I said that earlier. Xcomp is another program I found, which is a recursive file compare utility. For example, if you have a disk full of files, which we generally do, and there are a lot of duplicates, one way, of course, is to go through, find all the names that are the same, see if the file sizes and the date and timestamp are the same, and then we assume they're the same. Of course, if you went through all files, generated an MD5 checksum, and then you just found out the checksums that are the same, those are the true duplicates, even if you're going to rename. So that is also a method. And there are probably a lot more programs that use MD5. At least command line programs. I don't know. Okay, to calculate MD5, there are a couple of programs on. There's MD5 OS2, which is on a Hobbes you can use. It is very simple, standard in or a file name, and you'll get the checksum out. Another version on Hobbes is MD5 sum L, L being large. That can handle files larger than 2 gigabytes. The syntax is almost identical, but this one also has the /d option for a divider, the hyphen. Here you can see a small example with the hyphen, without the hyphen. And you see, with the hyphen, it's a lot easier to read, especially if you want to compare something visually. Then we have some PM programs. PMDIGEST is one. And this can check or generate MD5 and also SHA-256, yet another checksum program. And here the option is you can change the hex characters into uppercase. Just readability. Then we have Sigma MD5. This program, in fact, can check lists of files and generate lists of files. Any questions up till now? No, okay. I'm wondering if I'm missing a bit now. Okay, as I said, you can check and save files to a list file. So you can check the integrity of files using that list file. And it's on your ECS disk. You've already got it. Maybe you didn't know. When you start booting your CD, you have the possibility to go to the, what do we call it? It's not the maintenance console, the maintenance, well, you can go to maintenance, put it that way. And you have then the possibility to ask LVM to partition your disk. You can do a command line and so on. You can also call up Sigma MD5, it's there. So before you in fact install your OS2, you can check that the checksums, for example, of the CD are correct. There's only one problem at this moment, and you probably heard that yesterday. On ECS 2.0, they have forgotten to put the list of the MD5 checksums on the CD. So that's why I was asking Joachim yesterday, would you mind if I posted on the internet, for example? But he said, well, it's a small bug. It will be back in the next release. On ECS 1.2, for example, you will find a list of MD5 checksums. Okay, we want to talk a little bit about the root. When a list is generated, it is only given a part of the path. There's no drive letter, and we don't really know where it is. So we need somehow always to indicate a starting path when we're doing a check. If we have a look at a typical sort of file structure with directories, we have something always like a root system, and there's always a bit somewhere that we want to do the check on. So this part, if we're going to generate checksums, we need to know when we put it back, where does it belong? Yeah? So there's additional information when we start to do checking. We need to know where we are checking from. If you just say an individual file, of course, you give a complete file name. But if you have a list of files, you have to give the root as well. This is an example for ECS Silver CD. Here's a checksum list. And what you see in the checksum list, this is standard. If there's a hash there, it's just comments. And all programs that can use lists see that as comment and ignore it. Then, as I said before, you get your checksum, the star, and the file name. And what you see is, after a while, you even start to get directories. But they begin somewhere, nobody knows where. In the case of the CD, they're going to begin at the root of the CD. So, if we were using Sigma, what we would do is, first of all, we would go and get this file. So, this file, we're going to say, okay, that's the file we want to use as our list file. Then we'd have to say, okay, where are the files we're going to check? And where is the root of those files? Now, simply enough, on ECS, the CD is going to be the root of your CD drive. That's typically the S drive. So we just say, okay, the directory is S/. And then the files will be checked. The very first one, then the next one, and the next one, and so on. And that's what will happen. Okay? Good. The big problem was always the root, because people don't always realize that I'm putting it somewhere. And the same is when you're checking, if you're generating files, you have to say, which part am I generating from? I will now try and give a demo. Oh yeah, plug it around, otherwise my mouse doesn't work. Yes, I'm alive. Okay. So here you see basically the program. You can open any file which has already been used before, or we can go and do it in a slightly different way. And this is the problem with all the extra dots. This is one way to get around them. It's not a nice way, but it works. Because then you will select also, but it is limited. Okay, what I will do, I will have a look. Oops, let's go on. Why not? Come on. Yeah, okay. Now, on the CD that I have in here, there is one MD5 Checksum file called this CD. If I've opened that file, I now have to say, okay, where am I going to check the files? Where's my root? Well, in this case, it's the same as the disk. So I can say, I can set it to where that directory was. Say, okay, and with a bit of luck, something should happen. Yes. Now it starts to read the files. What you see is, it says, I'm working, it's green, it's okay, I'm working, it's green, okay, yeah, fantastic. Everything's okay. So it's reading from that list of files, the checksum, and the file name. It then goes to the CD and reads the file, creates a checksum, and said, are the two checksums the same? And if they are, the file is good. As simple as that. This program doesn't only check, you can also create. So, for example, then I would have to say my selection path. I could do it from, I'll do the same, for example. Oh yeah, I have active filters with that. Okay. What you see is, oh no, I'll do it even more. I should take out the other one. Just, what you see here are all the files that I have on this CD. What you see also is there is no directory. So I can say, okay, I could add file for file, or just do add all. And what you see is I have now some duplicates, so I will clear all and do again. And now I could not add a duplicate. But what you also see is I'm adding the MD5 checksum file. It's a bit stupid. That's why I had in the filters exclude MD5 files. So I will add, you see that they're not here even, so then you would add all and it doesn't put a MD5 file in. This is not useful to generate a checksum of a checksum because if that's based on the files there, it's going to change. So you generally take that out. You might use it as a subcheck somewhere, but normally you take it out. And then you say, okay, finish. And because the CD takes a little while to warm up again, then it starts generating. And there we generated the same checksums. And then, of course, we could say exit. And he says, but you forgot to save them. But okay. So we say save, and we can save them. Of course, that's difficult to save to the CD, but the principle is you then have got that file. If we take something else, just to give you a feeling, we take ECS12. Okay. No, haha. I didn't double click the file, did I? If you only just select it, I have to say okay, or I double click it. Now, we start a recursive of all the files. This can take a little while because he's first of all finding out all the files that are available. This program can handle up to 1 million files, which should be enough for most purposes. But yes, wasn't it Bill Gates that said, who wants more than 128, 64K or something? So we've got all the file names, and I can say finish, and he starts to generate. And you see it is relatively fast. That is the advantage of this particular algorithm. It's a fast algorithm. And you see how many we have to go. I won't wait till it finishes, so we can just cancel. So basically, those are the sort of things you can do. You have, of course, various options, like you can switch off the separator. You can change your language. I always like the Chinese one. The problem is always going back. I go back to English then. So if you have errors, or I can do that easy enough. Let's go back, and we use the wrong route. Yeah, simply enough. And we say, okay, he thinks he's going to look here for those files. If I could get some good and some bad, what happens is, at the end, you can shift up all the bad ones to the top so you can see which ones are errors rather than looking through a complete list. The only extra things you have, you see here dupe file inhibit. That is, if I put that on, I can't add the same file again. Now you say, why would you want that? Well, often as not, you've got directories and then you take things out and you add things too, and it's stupid to have a double check in there. That's all that does. Sorting you can leave on or off. That's only handy when you're going through a list. You can immediately find a file back. It's simpler for us as human beings to go alphabetically sometimes. You have a number of options. You can include only certain sorts of files. Maybe you only want to do it on text files. Or you say, I'm only going to do my photos, so I want to only check my JPEGs. You can do an exclude filter because you're starting to go a little bit dement. You say, I don't think I want my photos. But, yeah. So you can do crazy things, but if I had to put the filter cross-checks on first, unfortunately it doesn't do that afterwards. Let's try it. This is for people of my age. So, but of course, this is a simple example, but sometimes you make filters and the one excludes the other, and of course that is then silly because you can use all the wild cards. But of course you could say, okay, I only want photos of my mistress and not the photo of my wife, so you can exclude whatever you like. Okay. You might say you only want certain dates. You might say you only want to have those files which have just recently changed archive bit, for example. You can exclude certain names. It's a shame. By default, there are 3 files which are in there, and I think I've accidentally removed them. But the page file system, which is in Windows, your swapper area, swapper.dat. There's no sense in making an MD5 checksum file of that, is there? Plus a file that's called workplace something or other. I forget it now. But if that is also standard in there, and the reason that's in there is if ever you try to do a checksum on it, it gives big problems. And I don't know why. And I don't even find the file normally. Okay. You can, oh yeah, we've got the default. That's it. Defaults. The workplace shell file. I don't know why when you try to access that file, it gives a problem. It's some form of system file that's protected in some way. Not normal ways. Sorry? Yeah. So you can add various filters to limit what you're making checksums for. So basically, let's go out of here. That's it. I have one small bug in here. You can't make it smaller than this, but you can try. Something for the children, you know. Try and get it smaller. Okay. Any questions on the program? Otherwise, I'll plug back. So basically, that's what MD5 checksums are. They're just a method of allowing you to check files are correct. And as I say, the most useful use is checking your CD, certainly after you've burnt it. And on the CD, there should be the MD5 checksum list file. And then you just double click that and you're away. And if it's okay, your CD's good. Oh. No. Yes, we had to come to that bit. Any questions? We've got 10 minutes for you to ask things to me. It's still very early, I know. Okay, I hope you enjoyed the presentation. I hope you've learned a little bit from it. And thank you.